Hello there, my name is Figa and welcome to MV Tutors. Now let's start with this. If you will need a tutorial session after this, feel free to visit our website www.mvtutors.co.za. You can book a session over there and you can also book a session over here by commenting under this video and asking for one. Other than that, today we are doing trig graphs. That's right. And if you look at this question here and you see that perhaps you might not be able to draw this graph, then stick around and let's learn the principles that you will need to know in order to solve this problem. Okay, so let's start with our sine graph. Let's learn, let's say sine theta, and then let's learn how each thing or each number affects the graph. So a normal sine graph is typically like this, okay? There, okay, where it's 0 there, 90 there. Oh, my 0 looks like a 6. 180 there. 270 and 360. That's a normal sine graph. Now, I want us to manipulate this slowly. Okay, so let's say now they give you this graph. They say draw this graph. Let's say they put a 2 there, and then they say sine theta. Okay, so one more thing I forgot to add on this one is that its amplitude is 1. We've got a -1 there. So now, how does this number affect the graph, you might ask? Well, basically, it affects the amplitude. Okay, and it really doesn't matter what that number is. All it does is just affects the amplitude. So the only thing that it does is that you would then extend your graph and since it's a 2, we just put a 2 there and a -2 there. It only affects the amplitude. So now at 90, it will be 2. At 270, it will be -2. All the other points at 0, it will stay 0, 0, 0. All the other points remain the same. Okay, so then our final graph will be like that. It will be just a longer graph. That's it. So this number, doesn't matter what it is. Even if they give you 1001 sine theta, all you would do then is just change this number to 1001. That's a -1001 there and a positive 1001. That's it. Right, so here we go again. We have the same original graph of a sine. Now, let's say they give you this. Let's say they put a 2 there, theta. Now, what does that affect? You might be asking yourself. Well, I'll tell you the answer just now. The answer is it affects the period. Now, what does that mean? What you have to do then is that you take each and every number and you divide it by that number. Let me show you what I mean. I mean, you will take 90, the first number, which is 90 degrees, divided by 2, and that's going to be equals to 45. The next number is 90, is 180, so we'll take 180, divided by 2, and you get 90. The next one is 270, so you'll take 270, divided by 2, you get 135. And the last one is 360 divided by 2. So that's the period we're talking about, and that's 180. So what period is this? It's the period it takes for the graph to actually complete its revolution, for it to be complete. So what does this mean? Where we see 90, 90 becomes 45. So we need to be able to say 45 there. It's going to be there. Okay? And 180 becomes 90. So our next point is going to be there. And then 270 becomes 135. 135 is somewhere here. It's in the middle. 135 there. And then lastly, the period 360 becomes 180. Okay, now check this out. Where it's supposed to be 90, it's supposed to be 1. So the graph moves there. Where it's 180, the graph is 0. Where it's 270, the graph is 135. So it comes down here. And then back at 180. Now this means that when we draw a graph, it's like that. That's it. That's all it affects. All right, here we are again. So this is the original graph right here. Now, let's say they give you this. Check this out. Let's say they give you that. Sine, and then brackets theta minus 30. Okay, what does that affect, you say? Well, that is a shift on either left or right. Now, whether it shifts left or right, that depends on the sign, whether it's negative or positive. If the sign is negative, then that is a shift to the right. If it's positive, it's a shift to the left. Yes, that is right. I know you thought it would be opposite of that, but think of it this way. If you have something in a bracket, like when you are solving for x, and you equate it to 0, what happens is that when you solve for theta here, when you take the 30 to the other side, it changes sign and it becomes positive. That is why then you make a positive shift to the right. So the opposite is true, that if you have a plus 30 then in the bracket and you solve for theta, it becomes negative 30. So that's a shift to the left. Think of it that way. Okay, so let us draw this graph. That means then 90 becomes, you're just going to add 30. Okay, because we have a minus here, so we take the opposite of it. So we got to add 30 to shift it to the right. Okay, so 90 plus 30 is 90, 100, 110, 120. It becomes 120. And then the next number is 180. So it's going to be 180 plus 30, which is equals to 180, 190, 200, 210. It becomes 210. And then the next one is 270 plus 30. So that becomes 300. And then the next one is 360 plus 30, which is 390, becomes 390. Now I go to my graph. First one is 120. Let's say 120 is over there. Next one is 210. 210 is over there. Next one is 300. 300 is over there. Then the next one is 390. 390 is over there. Okay. Now 0 as well, because we have a 0. So 0 plus 30 is equals to 30. That means that our graph will start at 30, which is there. Okay, so 90 and 1 becomes 120 and 1. That's our point. 180 is still gonna be 0. 360, 270 becomes the 301 over there. Okay, so that means our new graph then, which has shifted, is going to be like that. Not very neat, very shaky. Let's do that again. It's going to be like this. Okay, and then it's going to turn there, and then it's going to come down to 210, and then it's going to, from 210, it's going to come down to 300. From 300, it's going to go to 390. That's it. So the entire graph just shifted to the right. Well, there is that graph again. Y is equals to sine theta, the original graph. Now, let's say they give you this to draw. Let's say draw y is equals to sine theta minus 2. Now, what does that number affect? Yes, you guessed it. It's a shift either up or down. If you say this is a shift down, then you are correct. This is going to be a shift down. Okay, so we just shifts the original graph down. That means each and every amplitude shifts by 2 going down. So this 0, 1, it's going to become it's going to shift 2 units down, so it moves from 0 minus 1. So we need to add a minus 2, so it comes to minus 2. All right, that's our point there. And there, the 1 shifts down twice as well, from 0 to minus 1. 180 moves from 0 to minus 1 to minus 2. There. Okay, just there. And then this one, it moves from minus 1, it needs to shift twice. It goes to minus 2 to minus 3. Okay, so we need a minus 3 as well. So it's gonna move to minus 3 right there. And then 360 from 0 to minus 1 to minus 2. That's a shift. So the final graph, which has shifted twice, is gonna look like this. There we go. That's it. That's a shift down. This is our graph. Good. Now, at this point, I'd like to do the course graph, but the way the course graph moves is exactly the same as the sine graph moves. The only exception is the tan graph, and that is what I want us to focus on right now. Now, the normal tan graph is like this. Okay, it also has 90, 270. No. From 90, we have 180, and then we have 270, and then we have 360. Right. Now, there is something I want you to know about a tan graph. First of all, it has what we call an asymptote. Okay? And the asymptote is on 90, and it's also on 270. It's what we call the asymptote. Now, what's an asymptote? It's where the graph it wants to reach the point, but it doesn't touch it. It actually goes towards it but doesn't touch it. Okay, so let's see what that looks like. The full tan graph looks like this. this is the full 10 graph. It reaches the asymptote but doesn't touch it. And also this side, it reaches the asymptote but doesn't touch it. Okay, so this is the full 10 graph. As you can see, from 90 to 270, it has a period of 180 as opposed to 360, like the sine and the cos graph. So from 0 though, it's gonna look like this. The 0 part is this one, and then the 360 part is this one. So from 0 to 360, it looks like this. But if you wanted to make it a little bit its true form, then you have to go, to these ends here to make it full like this. So its period is 180. That's it. That's all you have to know. This is the original graph. And also, just to add on it, it has no amplitude. So you can't put a 1 there. It can be anything. It can be 1 there. It can be 1001. It really doesn't matter. It has no amplitude like the sine and the cos, which are basically just confined from 0 to a positive 1 to a negative 1. But this one, none of that. No amplitude at all. Remember that. So we've got our original 10 graph over here. Now, what happens if we're given y is equals to, let's say, 2021 tan theta? Well, it's exactly the same as we did last time. We're just gonna put 2021 over there, and here we put a negative 2021. That's it. So here we go again. We have our original tan theta graph. Now, what happens if we have, let's say, we're given y is equals to tan a half theta? Okay, just like the previous one, it affects the period. Now, let's take each and every number on its own. So it's 9 divided by a half, which is, it's dividing by a half is just like multiplying by 2. So 90 becomes 180. 180 divided by a half, that becomes 180 times 2 is 360, and then 270 divided by a half. My goodness, what is 270 times 2? So we've got 270 times 2, 540. Okay, and then the last one is 360 divided by a half, which is equals to 720. Okay, so that means at 90 we have an asymptote. Our new asymptote is gonna be at 180. Okay, right there for this new graph. And then 180 becomes 360, so it's gonna be 0 there, which means our graph is gonna start there. And then 270 becomes 540, so I have to add a 540 right over there. And then 360 becomes 720, so I'm going to add 720 right over there. So where's our other asymptote? Is at 270, so at 540 we have our second asymptote right there. Okay, so now the complete graph is starting at 360, which represents 180 from the original graph. Goes like that, and then towards the asymptote, it doesn't touch it. And then this side, our 90 became 180. So that's our asymptote. It's still from 0. It goes towards it, doesn't touch it. Okay, and then our 360 became our 720. So from 720, we go towards the asymptote and not touch it. So the half, it actually doubled the graph. That's what it does. Okay, that's our original graph once again. Now let us say they give you, let's say draw this one, 10, and then bracket theta plus 30. What are you going to do there? Okay, so this is a shift to the left. Remember, if you have brackets, you equate them to 0, and then what you do is solve for theta, and then theta basically here is going to be negative 30. So that means each and every point you put, you're going to subtract a 30. So let's start with 90. So we're going to say 90 minus 30. What's 90 minus 30? That's 60. So 90 becomes 60. The next number is 180 minus 30, which is 150. The next one is 270 minus 30, which is 70, it's 240. I think so. And then the last one is 360 minus 30. That's gonna be 330. Okay, so let's find these numbers. Oh, and here we have 0 minus 30, which is equals to minus 30. Okay, so that means 0 becomes minus 30. Okay, and then 90 becomes 60. 180 becomes 150. And then 270 becomes 240. Okay. And then 360 becomes 330. Okay, so we have an asymptote at 90, so 90 became 60. So now our new asymptote is at 60. And then our next one was at 270, so our new asymptote is at 240. Okay, and then our 180 became 150. So our graph then is like that. Okay, goes towards the asymptote but doesn't touch it. That's our full graph. I like to always start with the full graph, and then I can add these other ones. So this other one here starts at negative 30, and then this other one starts at 330. It's like that. Okay, so what happened? Everything shifted to the left. That's it. Okay, so here we go again. We have original graph. Now let's say they give you to draw y is equals to 10 theta plus 2. Yeah, this is a shift up. So we shift every point by 2. So this one needs to move to, let's say 1 is there, moves to 2. That's 1 there. Basically that's all we need, because the original graph is gonna move there, that 180. Asymptote stays the same. It's gonna move there, and then 360, it's gonna move there, and then 0 as well, it moves there. Okay, so what does this mean? 180 are our full graph It's like this. Okay, and then from this side, from 2 towards the asymptote, not touch it. And then this side, from 360 towards the asymptote and not touch it. That's it. So the graph just shifted up by 2 units. Okay, so now we have learned all the principles that we need to answer this exam past paper question. We already know that this is a shift to the right by 30, and also we already know that that affects the amplitude. Okay, so here we go. We have that. What we're gonna do, we're just gonna say 90 becomes, so we're gonna do this exercise, 90 plus 30 from the original, which is gonna give us, what's 90 plus 30? It's 120. And then we're gonna have the next one is 180 plus 30, which is 210. The next one is 270 plus 30, which is equals to 300. The next one is 360 plus 30, which is 360. Now, I want you to pay close attention to the bounds that we've been given. They say we must draw it from minus 90 to 270. Okay, now I want us to take this slowly. So let's start with the original graph so that things are clear. You can draw the original graph with a pencil lightly, just to give you perspective. Okay, so we're supposed to have 90 there, 180, 270, and 360. Okay, that's the original one. Now, also originally, this one continues to minus 90 to 180. So it continues like that. Okay, it just repeats itself. Now, these are the bounds. Let's put the bounds in. They said they want this graph from minus 90, which is there. Maybe I should make it dotted. But don't assume it's an asymptote. It's not. It's just the bounds we've been given. And 270 over there. Cutting the graph there. Okay. The rest is just shifting. Okay. So what does this mean? We're starting at minus 90. So minus 90. Let me wrap that. We have to draw the correct graph now. It starts at minus 90. Let's add. So minus 90, if we add 30, it's going to become minus 60. Okay? Right. So that means it's over there. We are missing also 0 plus 30, which is equals to 30. So 0 becomes 30. It's minus 60. 90 becomes what? 120. Over there. 180 becomes 210. 270 becomes, do we need it? We don't need it, but it will become 300 because it's outside of our bounds. So let us draw the graph now. At 90, it's supposed to be there. No, it's not the case. At 90, it's supposed to be there, the apex. at the amplitude. Now, our new amplitude, because we have a 2 here, that means our amplitude is actually going to be 2 here and negative 2 there. And then the rest is just the shift. Okay, so 90 became 120, 180 became 210, and then it came down here, and then it started at 30. So let's draw it from the original 30. So it's like this. Bam, and then it's gonna stop there. And then this side, it's gonna continue like this. No. Remember, at minus 60, it should be, actually, it should be minus 2. So it's gonna go like that. Bam. That's it. That's our answer right there. Remember, you're only gonna draw on a hard pencil the red graph, but on the, you can use a light pencil to draw the blue graph. That's it.